All right, mathletes. So here we have a function or a problem where we're trying to determine the intervals of where the function is increasing or decreasing, which remember deals with the first derivative, positive for increasing, negative for decreasing, right? And that's the first derivative. In this case, we're dealing with x, so we'll call it x prime. And then concavity, concave up or concave down, positive for up, negative for down, and that's dealing with the second derivative, right? So what we want to do is we want to find the first and second derivatives of this function here, and then we're going to set them equal to 0, find out basically where they're equal to 0, and then we'll use those to give us endpoints in the intervals, and then we'll determine in those intervals by plugging in values whether the derivatives are positive or negative in those intervals. Okay, so let's start by finding the first derivative of x of t. So x primed of t is going to be 4 times 3 is 12. Take away 1 from the exponent. Negative 8 times 3 is negative 24. Take away 1 from the exponent. And negative 18 times 2 is negative 36. Take away 1 from the exponent, right? So I'll deal with that in in a second. More on that in a second. That's what I meant to say. And so then with the double prime, I'm going to take the derivative of this, right? So 3 times 12 is 36. Take away 1 from the exponent. Negative 24 times 2 is negative 48. Take away 1 from the exponent. And then the derivative of negative 36t is just negative 36. All right, so let's set this equal to 0, and I'm going to factor. So 12t is a common factor here, so I'm going to factor out a 12t, and I'll end up with t squared minus 2t minus 3. All right, and so here we have a simple quadratic. So we're looking for numbers that we can multiply to get 3, right? Numbers we can multiply to get 3 that we can subtract to get 2. And those numbers are 3 and 1. And this tells us the sign of the bigger number. So 3 will be negative. And since this is negative, that means our signs will be different. And so that means the other number, the smaller number, will be positive, will be different, right? Okay, and so that leads us to our critical points, right? We get t equals 0, t equals positive 3 from here, or t equals negative 1 from here. All right, so now we have our intervals, right? If we have 3 critical points there, 3 0 points in the first derivative, that'll give us 4 intervals of increase or decrease. And so since negative 1 is the smallest number, I'm going to go from negative infinity to negative 1. Okay, and then we'll go from negative 1 to 0, and then we'll go from 0 to 3, and then we'll go from 3 to infinity. All right, so what I want to do is just find a value in those intervals that I want to plug into the derivative, right, to figure out if the derivative is positive or negative in those intervals, right? I know it has to be all one or the other in each of those intervals, right? Because the only places it turns out to be 0 is here, and so that means everywhere else it's going to be not 0, which means it's going to be either positive or negative, right? And since it doesn't cross 0 in any of these intervals, that means that it has to be all of 1, right? Because it can't pass, and this is a continuous function. All right, so for this one, let's plug in a value like negative 2. So I'm going to find x primed at negative 2, and what you can do is plug this in your calculator, and then you can just go to you can actually just do trace negative 2, enter, or you can do second trace 1, and then plug in negative 2 and push enter. But either way, when we plug in negative 2, we get negative 120, right? Which doesn't matter exactly what it is. What matters is that it is less than 0, right? It's negative, which means this is an interval of decrease. But decreasing. Okay, so that's one of our intervals. So now let's do a similar thing with this one. So negative 1 to 0, so it's a smaller interval, So let's pull in, let's put in negative 0.5 here, okay, and see what that comes out to be. So I'm going to do the same thing in my calculator. I'm just going to do, and there's just one way you can also plug it in, just by using this expression and putting this value in there for x, where x is. But I'm going to do it with the trace method. So I'll plug in negative 0.5 and I get positive 10.5, right? So x prime is positive, greater than 0, so that means this is increasing. And a lot of times these alternate, but they don't always alternate, right? So that's why we have to check. And so here x prime will use 1, which is easy to do, right? If I plug in 1 here, I'm just going to get 12 minus 24 minus 36. So that's obviously going to be negative. It'll be negative 48 to be exact, but negative is the key there. And so that'll be an interval of decrease, so decreasing. All right, and last but not least, let's plug in, you can plug in whatever you want. Here, since we're using our calculator, it doesn't really matter. I like to plug in 5 rather than 4, just because to me it's a little easier to operate with than 4, or just kind of remember more of my multiplication facts and things with 5 maybe. But if I plug in 5, what I get is 720. So main thing is, once again, that it's positive. Oops, I forgot the prime there. And so this is increasing. All right. Okay, so we have those intervals of increase and decrease. All right, and then now we can do a similar thing with the second derivative for concavity, right? So we can set this second derivative equal to 0. And here, the greatest common factor is 12, so I'm going to factor out a 12. And I get 3t squared minus 4t minus 3. Okay, now here we have a complex quadratic, right? Since a is bigger than 1 here, we could multiply a times c, and then find numbers we can multiply to get that we can subtract to get 4, and we can go that route. And actually, just on a real quick glance, it seems like that's not possible. And so, yeah, I think the quadratic formula is a good way to go when you have a complex quadratic that you're trying to solve. So I'm going to say, okay, well, t equals negative b, so b is negative 4 in this case, right? So here's a, b, and c, of course. And so, so we have negative 4 plus or minus the square root of b squared, negative 4 squared, minus 4 times a times c, right? And then 2 times a on the bottom. All right, and so now negative negative turns into a positive. So I'll get positive 4 plus or minus. And then underneath this radical here, we'll get 16 of negative 4 squared is 16. And then here we'll get positive 36, right? So 16 plus 36 is 52. So we'll get square root of 52. And that simplifies to 2 root 13. All right, and then 2 times 3 on the bottom is 6. And let me know if you need help with like simplifying that, radicals and things like that. I know it's probably been a while. And so this is 2, this is 3, this cancels out to 1. And so we end up with 2 plus or minus root 13 over 3. And remember that that's really two different values, right? That's 2 plus, or let me do the minus first, 2 minus root 13 over 3, and then 2 plus root 13 over 3, okay? So when we do our intervals, we're going to have 3 intervals, right? Since we have 2 zeros, we're going to have 3 intervals. So we're going to go from negative infinity to 2 minus root 13 over 3. Okay. Then we're going to go from 2 minus root 13 over 3 to 2 plus root 13 over 3. And then we're going to do one other interval from 2 plus root 13 over 3 to infinity. Okay. All right. And so, so now I just need to plug in values in those intervals, right? And so let's see. So here, and you might want to approximate these values, so just like plug those into your calculators. So like 2 plus, let me make sure this is a fraction. So let's see, this is approximately negative 0.5, it's 0.53, etc., right? And then this is 1.86, etc., right? And so just to give you an idea of like what to plug in these intervals. So first, let's plug in, since this is negative 0.5, we can just plug in negative 1, right? So x double primed at negative 1. All right, so we're going to plug in negative 1 into this function here. And you can plug it into this version too, either way. So if you plug in negative 1, you get positive 48, so meaning x double primed is greater than 0, so that means this is concave up. All right. And then here, this one, since one is negative and the other one's positive, we can just plug in 0, so that makes it easy. So x double primed at 0 gives us negative 36, right? So that's going to be obviously less than 0. And so this is concave down. All right, and last but not least, it seems like these are alternating, but once again, just want to double check. So we can plug in a value like 2, yeah, whatever you want, anything greater than 1.86 or whatever it was. And so we'll do x double primed at 2. And we get positive 12 when we plug in 2. So x double primed is greater than 0, meaning this is concave up. All right, so those are our intervals of concavity and increase or decrease. So yeah, let me know if you have any questions, or if you see any errors or anything like that, let me know as well.